So this is my predicted paper for the 16th of May 2024. It is a best guess. No one knows for sure what's going to come up, but we can look at previous papers and see what tends to appear quite a lot, and I've had a go at that for you. So I hope you enjoy it. There's lots of other stuff for you. Scan the QR codes if you want more content there. Question number 1, and I've gone for multiplication. So to do 4.08 times 3.7, there are 2 methods here, and I would like you to be using one or the other ideally. So 408 times 37, and I'm going to do this in the traditional way. So 7 times 8 is 56, 7 times 0 is 0, add the 5 is 5, and 7 times 4 is 28. So that's your top row. Now moving over to the 3, but it's actually 30, so we do need to put a 0 in there. 3 times 8 is 24, 3 times 0 is 0, add the 2, and 3 times 4 is 12. We're then going to add that together, and that is 6. 5 add 4 is 9. 8 add 2 is 10, so 0 carry the 1. 2 add 2 add 1 is 5, and then I've just got the 1 there. Now we would put the decimal point back in. So there's no point doing it with the decimal point in. That always leads to confusion with where it goes at the end. I would just multiply with the digits, and then we'll worry about that decimal point at the end. Now there's a few different ways you can work out where to put the decimal point. This is roughly 4 times 4. If you were going to round it, it would be 4 times 4. And we know that 4 times 4 is 16. So I know the answer is going to be fairly close to 16. So it makes most sense for me to put my decimal point here. What other ways could you do it? Well, you could say there are 1, 2, 3 values after the decimal point in the question. So there's going to be 1, 2, 3 going back from the end there afterwards. So 15.096. I'm happy that that makes sense, and that would be my answer. Method number 2 would be the lattice method. Now to do this, you're going to need to draw a grid that is 3 boxes wide, because I've got 3 digits in that first number, and 2 boxes tall because I've got 2 digits in that second number. So I'm going to write that over the top, 4.08 multiplied by 3.7. Every single box needs to get split diagonally going down to the left. So diagonally like that. And I would split each box individually because it goes wrong less often. And then we just on the ends want to make them a little bit longer, so we've got somewhere to write our answer. Now all you need to do with this one is multiply the number at the top by the number at the side. So 8 times 3 is 24, so I'm going to put 24 there. 8 times 7 is 56. 0 times 3 is 0, so we put 0, 0. 0 times 7 is 0. 4 times 3 is 12. And 4 times 7 is 28. Now it is worth saying, if you got a number less than 10, let's say you were doing 3 times 3, you would write that by putting 0, 9, for example, in the boxes. But we didn't have any numbers less than 10 there. And then all you do is add down each diagonal section like this. So in my first diagonal section, I've got a 6. 4 add 5 add 0 is 9. 2 add 8, that's 10, so 0, carry the 1 into the next diagonal section. 2 add 1 is 5, and then I've just got 1 in that section there. And that's my answer, 15.096, same thing. Now, what you need to do is go to the top where you've got a decimal point, and the side where you've got a decimal point. If you go across with one and down with the other, wherever they meet, you can go down that diagonal, and that tells you to put the decimal point there. So whichever way you prefer, but I would be really confident with one of those, and make sure you get your family members to quiz you, give you some decimal numbers to times together, and then check it on a calculator. Make sure you're super confident with that for 3 marks. Question number 2, work out 4 divided by 2 2/3. Give your answer as a mixed number in its simplest form. So when we are dividing fractions, most of you will know to keep, change, flip. But our first number here is an integer, it's a whole number. So I'm going to write 4 divided by. Now, the first thing we always need to do when we've got mixed numbers, whether we're adding, subtracting, multiplying or dividing, is make it top heavy. Now, 2 2/3 is 2 wholes and 2 out of 3, so 2/3 like that. So you've got 3/3 every time you have a whole. So we do the big number times the bottom number, because 2 wholes is 6/3, so 2 times 3 is 6. Add on that top number. So 2 times 3 is 6, add the 2 is 8. So 2 2/3 is 8/3. And then we're going to do 4 multiplied by 3/8. When we divide by a fraction, it's the same as multiplying by its reciprocal, which means inverting that fraction, turning it upside down. So keep, change, flip is how we often remember that. Now this is a little bit tricky because we've got that integer, that whole number. So you might find it helpful to make it 4/1. 4/1 is the same as 4. So that's all good. And now we can just do what we would always do for multiplying fractions, and that is multiply the numerators together. So 4 times 3 is 12. And multiply the denominators together, so 1 times 8 is 8. Now, that is not a mixed number, and it's currently not in its simplest form. So how many 8s go into 12? Well, that fits in one whole time, with 4 left over out of 8. And then that fraction part there, 4/8, they're both in the 4 times table, so we can divide both the numerator and the denominator by 4, and that is 1½ as your final answer. Question number 3, write 72 as a product of its prime factors. Give your answer in index form. So for this, we want to start with 72 at the top and split it up into any two numbers that multiply together to give 72. You might do 36 and 2. You might do 8 times 9. I'm going to go 8 times 9 because why not? Then you need to think, are either of these numbers a prime number? Now I've got 2, 3, 5, 7, 9's not a prime number because it's in the 3 times table. You've got 11, 13, like 15's not because it's in the 5 times table, 17 and so on, okay? These are all the numbers that have two factors, 1 and itself. They're only in the 1 times table or their own times table. If you get to a prime number, you're going to circle it, but if it's not prime, you're going to carry on. So 8 is 2 times 4, and 2 is prime, so we'll circle it. 4 is 2 times 2, so we'll circle those because they're prime. And 9 is 3 times 3, and they're both prime. Now, that is a correct tree, okay? And we could have done it a different way. You could have said 72 is 2 times 36, and then maybe 6 times 6, 2 times 3, and 2 times 3. Doesn't matter how you do it, you end up with the same answers, okay? We've got a 2, a 2, a 2, a 3, and a 3. So we're going to write that as 2 times 2 times 2 times 3 times 3. It is the product of its prime factors, and product means multiply. If you did 2 times 2 times 2 times 3 times 3, you would get 72. So we know we've done it correctly. However, it says give your answer in index form. So that means where we've got 2 times 2 times 2, we need to write that as 2 cubed times 3 squared. There we go. For part B, find the lowest common multiple of 72 and 90. Now we've already got 72 written as the product of its primes. So 2 times 2 times 2 times 3 times 3. That is how you make 72. I'm going to do the same for 90. So start with 90 at the top, and I'm going to do 9 times 10. 9 is 3 times 3. They're both prime. And 10 is 2 times 5, and they're both prime. And I'm then going to do a Venn diagram. And I'm going to have 72 on one side. Let's do it over here because I've got my 72 up here. And 90 on the other side. And what they've got in common can go in the middle. So 90 is 2 times 3 times 3 times 5. So both of these product of primes have 2's. So we can put the 2 in the middle. We can also put a 3 in the middle because they both have a 3. And they also have another 3. So we can put another 3 in the middle. However, there's nothing else left in common. The 72 has 2 and 2 left over, and the 90 has a 5 left over. If I asked you for the highest common factor, you would multiply together all of the numbers in the middle. So if I'd asked you for the highest common factor, which is the biggest number that fits into both, you would do 2 times 3 times 3. Now 2 times 3 is 6, times that by 3 is 18. So if I'd asked you the highest common factor, we would say that is 18. But I haven't. I've asked you for the lowest common multiple, which instead of being the biggest number that goes into both, is the first number in both their times tables. So you could have done this by writing out the 72 times table, 72, 144, and so on, and also writing out the 90 times table, 90, 180, 270, and so on. And the first number that you get to of both is going to be your lowest common multiple. But I find this way easier. So I've got my 18 by timesing together the numbers in the middle, and I'm going to times that by what's left on the outside. So I need to take that 18, times it by 2, times it by 2, and times it by 5, because those are the numbers that are left on the outside. Now, a bit of a sneaky trick here is that 2 times 5 is 10. So if you can save that till last, that's going to save you a bit of work, because 18 times 2 is 36, and we can then times that by 10 using up the 2 and the 5. So my answer here is 360. And if you'd have carried on going with both of these times tables, you would have got to 360 as the first number in both their times tables. Now, it doesn't matter what method you use there, but I tend to see this go wrong less often. When people write out the times tables, tend to miss 1 or miss 10 and go wrong that way and miss it. So there we go. That's 4 marks for that one. A really common question on the non-calculator paper. Question number 4. Billy, Nikki and Katie share some money. Billy and Nikki have £240 in the ratio 3 to 5. Okay, so when we're doing ratio, you guys will know I like to do my little lines here. 1, 2, 3, 1, 2, 3, 4, 5. So Billy has these 3 piles of money and Nikki has these 5 piles of money. So altogether they've got 8 little piles, and we know that we need to take £240 and share it over those 8 piles so that each of the piles has the same amount on it. So 240 divided by 8 is 30. So that means each of these little piles has £30 on it. 30, 30, 30, 30, there we go. Which means that Billy has £90 in total from those 3 piles, and Nikki has 5 piles of 30, so 5 times 30 is 150. 30 times 5. There we go. So then it says the amount of money that Nikki has to the amount of money that Katie has is in the ratio 3 to 2. Okay, so now these 3 piles are where Nikki's money are, and these 2 piles are for Katie. Now, we already know that Nikki has £150. So now if I had to share it over 3 piles instead, I'm going to take that 150 and share it equally over 3 piles, which is 50. So I've then got £50 here, £50 here, and £50 here. And with ratio, if those piles have 50 on them, then we know that these piles have 50 on them as well. So we're asked how much money does Katie have, and we can see that Katie has £100 because she has 50 and 50 on 2 piles, so £100 would be your answer there. Question number 5. There are only pink cubes, grey cubes and white cubes in a box. The table shows the probability of taking at random a pink cube from the box. The number of white cubes in the box is 3 times the number of grey cubes. Complete the table. So we know that with these tables, they always need to add up to 1. Probability adds up to 1, and so far we've got 0.4. So my first calculation here is to do 1, take away 0.4, which leaves me with 0.6. So I know that whatever I make these probabilities, they need to add together to make 0.6, okay? And then the whole thing will add up to make 1. Now it says that the number of white cubes in the box, this value here, is 3 times bigger than the number here. Now there's a couple of different ways you can do this. I could say that grey would be x and white would be 3x. Because this number has to be 3 times bigger than that number. And together they make 0.6. So x add 3x equals 0.6, which means that 4x, because this is 1x, equals 0.6. If we divide that by 4, now 0.6 divided by 4. 4 doesn't go into 0, and 4 goes into 6. 1 time remainder 2, but we've got nowhere to carry that 2 onto, so I need to put a 0 here. There's nothing in that column at the minute, so I can carry the 2 onto it. 4 into 20 goes 5 times. Therefore, x is 0.15, which means grey is 0.15, and white is 3 of those. 0.15 times by 3 is 0.45, or you can take it away from 0.6, doesn't matter. There we go. So we've completed the table. That would be correct. Another way of doing it, again, would be to use that ratio. So grey to white, you know it's in the ratio 1 to 3, and you know that all 4 of those have to be worth 0.6, so it's still going to be 0.6 divided by 4, and each of those piles has 0.15 on it, and that's how you get your answer that way. So you can use ratio or you can use algebra, it's completely up to you. 2 marks there. Question number 6, and we've got standard form. Write 0.00209 in standard form. So standard form is when you have a number between 1 and 10. It can't be 10, but it can be 1, times by 10 to the power of something. Okay, so because this is a really, really small number, it's going to be a negative power up here. We're going to be dividing by 10 rather than timesing by 10. And if you want to divide by 10, we still write times, but we make the power negative. So the digits I need between 1 and 10 would be 2.09. These are the digits I want, but I have to make it between 1 and 10, so 2.09. However, if I want it to be 2.09, let's zoom in here. If I want the 2 point to go there, then I would need to divide by 10, divide by 10, divide by 10. Now, it's the values that are moving when I divide by 10. That 2 is moving column, the 9 is moving column, the 0 is moving column, but it's much easier for us to bounce that decimal point to show our working. So there we go. I've had to divide by 10, divide by 10, divide by 10 for that 2 to go from the ones column into the thousandths column where it is now. So that means because we've divided by 10 3 times, I'm going to write that as 2.09 times 10 to the power of minus 3. And that would be my answer for that one. For part B, 1.302 times 10 to the power of 4. Now 1.302, I'm going to times it by 10 4 times. That's a positive power, so we know we're just timesing by 10, we're not dividing by 10. So if I times it by 10 once, I'd get 13.02, so that's going to go there. Times by 10 again, times by 10 again, times by 10 again. And we'll put a 0 there to hold the place value. So this is going to be 13,020 as our answer. So 13,020 goes there, and 2.09 times 10 to the power of minus 3 goes there. 1 mark for each of those. Question number 7. ABCDE is a pentagon. EDF is a straight line. Angle CDE, so CDE, so that's the angle that's made there, is 30 degrees greater than angle BCD. BCD, that's the angle that's made there. Okay, work out the size of angle X. You must show all your working. So we know that this angle here is 30 degrees bigger than this angle here. So let's call this angle Y, and let's call this angle Y add 30. I don't want to use X because X is already at play over there. So Y and Y add 30. And we know that angles in a triangle add up to 180 degrees. Angles in a quadrilateral, a 4-sided shape, add up to 360. And every time you add a side, you add another 180 degrees. So a 5-sided shape, a pentagon, adds up to 540. And the formula for that is the number of sides, take away 2, times by 180. But if you forget that formula, it's kind of nice to be able to work up. So triangle's 180, and then every time you add a side, you add another 180 degrees, just in case you forget that formula in the exam. So here we go. We've got a 5-sided shape, and we know that that adds up to 540. So far, what have we got? So I've got 120, 105, and 71. Let's add those together so far. 120, 105, 71. So 0 add 5 add 1, that's 6. 2 add 0 add 7, that's 9. And 1 add 1 is 2. So I've got 296 degrees so far. Let's now take the 540 that we know it needs to add up to and subtract 296. Now, if you've got more on the floor and you're subtracting, you're going to borrow from next door. That 4 becomes a 3 so that we can make this 10. 10 take 6 is 4. 3 take 9. Again, you've got more on the floor. So let's borrow from next door. 13 take 9 is 4, and 4 take 2 is 2. Great. So we know that this one and this one, so y add 30, need to equal 244 degrees because that is what is left. We're then going to take 30 away from both sides. So 2y, because that's all I'm left with now, is 214, and then I'm going to divide that by 2. So y is 107 degrees. So that means that this one here is 107 degrees, and this one over here is 30 degrees bigger, so that's 137 degrees. Now we're being asked to show what the size of angle X is, and angle X is on a straight line with this angle here. So I now know that those two angles will add together to make 180. So 180, take away 137, again, more on the floor, let's borrow from next door. 10 take 7 is 3, 7 take 3 is 4, and 1 take 1 is nothing. So your final answer there is 43 degrees for the size of that angle there, angle X. Question number 8. Complete the table of values for y equals x squared minus x minus 1. So this is the rule that we're going to use. To get the y value, we need to take x, square it, take it away, and then take away 1. Now you might find it helpful underneath here to do x squared, to do minus x, and to do minus 1 separately. And then we can add those three things together and get y, okay? So that might be helpful. First, let's think about x squared. Now we're going to start by doing minus 1. Minus 1 squared is minus 1 times by itself. So minus 1 times minus 1, and that is 1. We then want to take away minus 1. Now what happens when we take away minus 1? It becomes a plus. I'm actually going to change that to just plus 1. But then we also need to take away 1. This is just following this rule. So to get our value of y here, we need to do this bit, and this bit, and collect it all up. So 1 add 1, take away 1 is 1. Now we're going to do the same thing, but for 0. So 0 squared is 0. Minus 0 is minus 0, it's just 0. And then we're going to take away 1. So altogether, that is minus 1. Now we're going to do the same for 1. 1 squared is 1. Take away x, which is take away 1. Take away another 1. 1 take away 1 is 0. Take away another 1 is minus 1. For the next one, I've got 2 squared, which is 4. Take away that 2, and then take away the extra 1. 4 take away 2 is 2. Take away 1 is 1. A lot of ones at play here. And then for the last value here, when x is 3, I've got 3 squared, which is 9, minus that value, so minus 3, and then minus the 1. 9 take away 3 is 6, take away 1 is 5. There we go. So those are our values here. And then these are the coordinates that we're now going to plot on the graph. So minus 1, 1 is here. 0 minus 1 is here. 1 minus 1 is here, 2, 1 is here, and 3, 5 is here. I'm just plotting each of those coordinates that I selected in purple there. And then we're going to join that up with a nice smooth curve. So like this. I'll do my best on the iPad. Oh, there we go, like that. And that is us drawing that quadratic graph. Then it says, using your graph, find estimates for the solutions of the equation x squared minus x minus 1 equals 0. Now this is what you've just drawn. When does it equal 0? And it equals 0 in two places, here and here. So I'm going to give the two x values in those points. Now I'm going to say this one is minus 0.6. And I'm going to say this one is 1.6. Each of those little lines is worth 0.1. So my two answers there are minus 0.6 and 1.6. And you might be slightly different just from the way you've drawn your curve. So maybe they might accept anything from 1.5 to 1.7, and they might accept anything from minus 0.5 to minus 0.7 there as well. So a small range of answers just depending on the curve of your graph, but should be very close to that. Question number 9, simplify t to the power of 4 to the power of 3. Now a power of a power, we multiply those powers together. So t to the power of 4 cubed is the same as t to the power of 12. Not to be confused with t to the power of 4 times t to the power of 3. That would be t to the power of 7, because when we multiply, we add the powers. So a power of a power, you're timesing them together, but when we times, we add the powers. So that's not what we're doing here. We're timesing the powers together. 4 times 3 is 12. Part B, simplify 20x cubed y to the power of minus 2 times 4xy cubed. So first let's look at the numbers. 20 times 4 is 80. And then we've got x cubed times another x. Now an x on its own, x cubed times another x, an x on its own is the same as x to the power of 1. And when we times, we add the powers. So that's going to be x to the power of 4. And then for the y's, we've got y to the power of minus 2 times y cubed. Y to the power of minus 2 times y cubed. Again, we're going to add the powers. And minus 2 add 3 is 1. So that's y to the power of 1, but we would just write y on its own like that, because we know that that's the same as y to the power of 1. So that's your answer for that one. Part C, work out 5 cubed times 5 to the power of minus 6, all divided by 5 to the power of minus 5. Now when we times, we add the powers. So we're doing 3 add minus 6. And adding minus 6 is the same as subtracting 6. So that's going to go down to minus 3. So our new numerator is going to be 5 to the power of minus 3. And we're dividing that by 5 to the power of minus 5. Now, when we divide, we take away the powers. So here we're doing minus 3, take away minus 5. And taking away minus 5 is the same as adding 5. So minus 3, add 5, brings you up to 2. So we've got 5 to the power of 2 here. Now, when it says work out, we actually want to write the value. So 5 squared, 5 to the power of 2, is 25. So 25 is my final answer for that one. And for part D, work out the value of 7 to the power of 0. Anything to the power of 0 is 1. So our answer there is 1. And part E, we've got a negative and fractional indice. So that's going to be 64 to the power of minus 2/3. Now, when we have a negative power, to use up that negative, we make the base number its reciprocal. Now, the reciprocal of 2 is a half. The reciprocal of 3 is a third. The reciprocal of 2/5 is 5 over 2. So we're inverting that number. So the reciprocal of 64 is 1 over 64. That's used up the negative, but we've still got this raised to the power of 2/3. Now we root by the bottom and do the power of the top. So the first thing I want to do is the cube root. Now the cube root of 1 is 1. And the cube root of 64, something times something times something that makes 64, that is going to be 4. And I then just need to square it, and those values squared, 1 squared is 1, and 4 squared is 16. So 1 over 16 is your final answer for that one. Question number 10. The frequency table gives information about the cost in pounds of 36 different products in an online store. On the grid, draw a cumulative frequency graph for this information. So sometimes they give you cumulative frequency up here, but it will say, and in this example, we've just got frequency. So that means we need to do the adding up. So for cumulative frequency, we're going to go 0 to 5, 0 to 10, 0 to 15, 0 to 20 for these categories. So for the first category, 0 to 5, that's still going to stay 2. But then 0 to 10, we would have the 2 and the 6. So we're going to add 6 on, and that would be 8. And then we would add the 10 on, and that would give us 18, and then we'd add the 12 on, and that would give us 30, then we'd add the 5, and that's 35, and then we'd add the 1, and that adds up to 36. So these categories are new. They're now 0 to 5, 0 to 10, 0 to 15, 0 to 20, 0 to 25, and 0 to 30. So it's everything up to that top of that category. And these are the values over here that we're going to plot. This is the cumulative frequency. And we plot for cumulative frequency at the top of the category. So you plot in the middle for a frequency polygon, and we also use the middle when we're doing the mean. But for cumulative frequency, you're always plotting at the top of the category. So I'm going to plot at these values, and this is going to be my cumulative frequency going on the y-axis. So across to 5 and up to 2, that's my first value. And then across to 10 and up to 8 for that second value. Across to 15 and up to 18, so that's there. Across to 20 and up to 30. Across to 25 and up to 35. And across to 30 and up to 36, which is there, joining up with a nice smooth curve there. And then it says use the graph to find an estimate for the interquartile range. So the interquartile range is your upper quartile, take away your lower quartile, and those values can be found 1/4 and 3/4 of the way through the data. Let me just get my straight line here. If I asked you for the median, you would need to go halfway through the data. Now, don't be fooled here by the fact that I went up to 40 on the y-axis. The top of the data is 36. That is where we went up to. So if I wanted the median, I would read across at 18. So reading across at 18 would give me the median, go down, and we would say the median is 15. Okay, now if I want the lower quartile, that's going to be halfway from that median to the bottom. So we read across at 18 for the median, so half of 18 is 9. So the lower quartile, I get 11 for that, because look, each of these 11, 12, 13, 14, 15. So 2 squares there is 1. So I get 11 for my lower quartile. And then for your upper quartile, you're going to read across 9 above 18. So halfway between 36 and 18 is going to be 27. So reading across at 27, hitting the graph and going down And for that, I get 16, 17, 18.5 for that one. So 18.5 take away 11 is going to be 7.5 as my answer for the interquartile range. You might have got slightly different, your graph, you might have read that value 0.5 different, but those should have been roughly where you should have got to for that. Okay, question number 11. Write 1.45 recurring as a mixed fraction in its simplest form. You must show all your working. So for this, let x equal 1.45454545, and those values keep repeating, and we want to show that by dot dot dot, or you can keep the recurring notation up there, but you do need to show something. Don't just stop. You will lose a mark if you don't show that that continues on. Then I want 100x. Now the reason I want 100x is because I want a value that lines up underneath. So I want these 4s to line up underneath 4s. So if I move it two place value columns over, the 4 will stay underneath the 4. If you times by 10, you'd end up with 4s underneath 5s, and we don't want that. So I'm going to try and squish this up to get it in like that, so that my decimal points are lined up. And then I've got 4, 5, 4, 5, 4, 5, 4, 5, dot, dot, dot. Brilliant. Now I'm going to do 100x, take away x. So I'm doing this backwards. I'm doing the bottom row, take away the top row. That would give me 99x is 144, because 4 take 4, 5 take 5, everything here has cancelled out when I've subtracted, but I've got 145 take away 1, and that's where I'm getting the 144 from. Okay, so then I'm going to divide both sides by 99. So x is 144 over 99. We want this as a mixed fraction, so we know that 99 goes into 144 one whole time, with 45 left over out of 99. But both of those values are in the 9 times table. So my final answer is 1 and 5 over 11, because I'm dividing that by 9 to get 5, and I'm dividing that by 9 to get 11. So 1 and 5/11 as your final answer there. Question number 12. The line L1 goes through the points -3, 5 and 1, 4. The line L2 is perpendicular to line L1 and goes through the point 3, -2. Find the equation of the line L2. So first thing we need to do is get the gradient of line L1. If two lines are perpendicular to each other, then we're going to do the negative reciprocal of the gradient. So if this line had a gradient of 2, then this line would have a gradient of -1/2. We're doing the reciprocal and we're also making it negative. So there we go. We can get the gradient of these 2 points by doing rise over run, or y1 minus y2 over x1 minus x2. So you can think of it in either way, whichever you find easier. I'm going to do y1 minus y2, so the y coordinate of one coordinate, take away the y coordinate of the other one. So I've gone for 4 take away 5, and I'm going to go the same way with the x values. So 1 take away -3. That is -1 over 4, because a minus minus makes a plus there. 1 take away -3 is 4. So if line L1 has a gradient of -1/4, then line L2 has a gradient of +4. The reciprocal of 1/4 is 4, and since L1 had a negative gradient, we know that L2 is going to have a positive gradient for them to meet at a right angle and be perpendicular. Okay, so I now know that the equation of line 2 is going to be y equals 4x plus c. We've got that gradient of 4, y equals mx plus c, m is the gradient, but we now need to work out the y-intercept. To do that, we're going to use this value here, and for this coordinate, x is 3 and y is -2, and if it lies on the line, those values will make this equation true. Both sides will be equal. So I'm going to substitute those values in. Y is -2, and that is 4 lots of 3 add c. So -2 is 12 add c. Taking 12 away from both sides, we can see that c is going to be -14. So the equation of line 2 is y equals 4x minus 14. That is the equation of the line. Question number 13. There are 8 boys and 12 girls in a class. The class has a test. The mean mark for the girls is 30 and the mean mark for the boys is 25. Work out the mean mark for all the students in the class. So if the mean for the girls is 30, that means they've got the total marks for the girls divided by 12, because there are 12 girls, and got an answer of 30. The mean is when you add it all up and divide by how many there are. So if we've divided by 12 and got 30, then doing 30 multiplied by 12, which is 360, that is then the total marks for all of the girls. So same thing for the boys, let's put G there. We've got the mean mark for the boys is 25, so there must be the total marks for the boys, which when we divided it by 8 boys, we got 25. So 25 multiplied by 8, that is going to be 200, and that's the total for the boys. Now if we add those two values together, 360 and 200, 360 add 200 is 560, so that's what they got all together, the girls and the boys, and we then need to divide that by 20 because there are 20 students in total in the class, and then that will give us the mean. So 560 divided by 20, if you get a tricky division on the non-calculator paper, write it as a fraction, and then you can just cancel that fraction down, both in the 10 times table, so it's 56 divided by 2, and that is 28. So 28 is your final answer there. Question number 14. Prove algebraically that the difference between the squares of consecutive integers is equal to the sum of the two integers. So if we have consecutive numbers, that means like 10, 11, 12. Those numbers are next to each other, consecutive whole numbers, consecutive integers. So we've got to prove that the difference between the squares. Now, if I've got two consecutive numbers, the first number would be n. The next number would be n add 1. And I want the difference between their squares. If I want the difference, that's going to be a subtract. So I want to make sure I've got the bigger number first. So that's going to be n add 1 squared, take away n squared. That's the bigger number. That's the smaller number, and we're squaring them and we're taking away. That would be the difference between the squares. And that we want to show that that is equal to the sum, which is just adding the two integers. So n add 1. Okay, let's expand this bracket. When we square a bracket, we write it out twice. So n times 1, 1 times n, and 1 times 1 is n squared, add n, add 1, minus the n squared that we've got from here, equals, and on this side, we've got 2n add 1. So n squared take away n squared leaves me with 2n add 1. So there we go, and that is equal on both sides, so we've shown that that is the same. Now, if you substitute in different numbers here, you could prove it for 30 different examples. You still would not have proved it algebraically, and you wouldn't have shown it for all numbers ever. Showing it for 30 numbers is not the same as showing it for all numbers. So even if you substituted in some numbers there, you wouldn't get any marks. You have to do it algebraically. Okay, question number 15. ABCD is a trapezium. A to B is 2 root 3, B to C is 5 centimetres, C to D is root 30, and angle BAD is 30 degrees. Work out the exact area of the trapezium. Okay, so the area of a trapezium is A add B divided by 2 times by the height, where A and B are your parallel sides. So A and B, and then height has to be going straight up. So to get the height, we're going to need that. We can find this side of the triangle here. Now, looking at this triangle, we do have a side and an angle, so we can use SOHCAHTOA, we can use trigonometry there, to find the opposite side. So let's do that. Let's label our sides. This side would be the opposite, this side would be the hypotenuse, and I don't want to know the adjacent right now, and I don't need to know the adjacent right now, so that's not going to be involved. So first, O and H tells me I need to use sine. So thinking about my SO triangle, cover up the thing you want to know and do the sum that's left behind. I want to know the opposite, so cover that up, and it's going to be S multiplied by H. So that's sine 30 multiplied by the hypotenuse, which is 2 root 3. Now, sine 30 is a half, and you would be expected to know that for the non-calculator paper. Half times 2 root 3 is just root 3. So the opposite here is root 3. Let me just get rid of that. Now, let's just do a little side note on exact values. So personally, how I remember them is I have two triangles that I remember. This one, like this, that is 60 degrees. 30 degrees, and 1, 2, root 3. And I have this one, which I remember, which is 1, 1, root 2, 45 degrees here, 45 degrees here. So as long as you remember those and you're confident with SOHCAHTOA or trigonometry, you can remember those. So for example, we just worked out sine 30. Now sine 30, we know that it is the opposite divided by the hypotenuse, because that triangle is so I'm going to go and stand in my 30-degree angle. The opposite is 1 and the hypotenuse is 2. So sine 30 is 1 over 2. So remembering those triangles enables me to work out any of the exact values involving 30 or 45 or 60. You just need to either do opposite divided by hypotenuse, or adjacent divided by hypotenuse if it's cos, or opposite over adjacent if it was tan. But that would help you to remember any of them. Okay, quick side note there. Right, back to the question. So we've now got root 3. Now I do know that this side is 5. That would be my A, so that's good. And I do now have the height, which is root 3. But I now need this length all the way along here to know what that bottom length is going to be, so that we can get B. Now, if I split this down like this, I know that this bit is 5. Can we work out, we also know that this is root 3, and we've got another right angled triangle over here. So we've got two things we need to work out, this part here and this part over here. Let's do this one first. So to work out that third side in this right angled triangle, I'm going to use Pythagoras. I've got two sides and I want to know the third side. Because we already have the hypotenuse, it's going to be root 30 squared minus root 3 squared. We're subtracting because we already have the hypotenuse and it's a shorter side that we want. So that is root 30 squared is 30, root 3 squared is 3, and that's going to be 27, and then we need to square root that answer. So root 27 is going to be my value down here. Now that simplifies. A square number goes into that, so now we're simplifying surds as well. When we simplify surds, we want to think about the biggest square number that fits in as a factor, and 9 is a factor of 27. So that's going to be root 9 times root 3, because 3 is what multiplies with 9 to make 27, and the square root of 9 is 3. So that side down there is 3 root 3. So now we've got that bit. Last but not least, we need this bit over here. Now again, I'm looking at that right angled triangle, but this time I want the adjacent, and you can use either. I'm going to use the opposite there. So I'm going to use the opposite being root 3, and I want to know the adjacent. So O and A is going to be TOA. So tan. Now if I want the adjacent, cover that up, it's going to be the opposite, root 3, divided by tan 30. And you might say, well, what's tan 30? Okay, let's go back to our formula triangles here. If I've got 30 degrees, I'm stood here, I want the opposite, which is 1, over the adjacent, which is root 3. So 1 over root 3. Now if you are dividing by 1 over root 3, so this is the same as root 3 divided by 1 over root 3, we know that when we're dividing by a fraction, we can multiply by the reciprocal. So that is root 3 times root 3 over 1, which is just root 3 times root 3, which is 3. So this side here is 3. You could also have got that by using Pythagoras. So there we go. Now, I've scribbled everywhere. Let me just draw another rough sketch of this. 5 is that one. At the bottom here, we have 3, add 5, add 3 root 3. And the height is root 3. Okay, great. So now, using this formula, A is 5. B is all of this, so that's 8 from the 3 add 5, add 3 root 3, all divided by 2 times by the height, which is root 3, and that is 13, add 3 root 3, divided by 2 times by root 3. Now I'm going to multiply this by each of these things, so that is 13 root 3, add. Now, when you have a root 3 times another root 3, it becomes 3 because you're essentially squaring a root. So I've got 3 here times another 3 coming from these, so that's 9, all divided by 2. Now, I was told to give my answer as an exact area, so I don't want to start breaking that down or worrying about it. That is going to be my answer. 13 root 3, add 9, all divided by 2. Well done if you got that. Very, very tricky, that one. Okay, question number 16. There are only 5 blue sweets, 4 yellow sweets, and 3 red sweets in a packet. Hannah takes 2 sweets from the packet. Work out the probability that the 2 sweets are different colours. So first she's going to take a sweet, and that's either going to be blue, yellow or red. Now we could draw the whole tree diagram for this. So first she's taking a sweet, blue, yellow or red, and then she's taking another one. So you'd end up with something that looks like this. Now we would be interested in any that are different colours. So there are 2 ways of doing this. We could do blue, yellow, red, and then do blue, yellow, red, blue, yellow, red, blue, yellow, red, and you're interested in this pathway, this pathway, this pathway, this pathway, this pathway, and this pathway. That's a lot of maths to have to work out. Now, all I'm not interested in are when it's the same colour. So because we want her to take 2 sweets of different colours, blue, blue I don't want, yellow, yellow I don't want, and red, red I don't want. But the brilliant thing about probability is that we know it all adds up to 1. So it's going to be easier for me to work out those 3 and then take them away from 1, and that will get me the 6 that I do want. So I'm actually going to do that instead. And I don't even need to worry about the tree diagram for that. It's a lot easier for me to just think about what those probabilities will be. So what is a probability of blue and then blue again? Well, the first pick is going to be 5 blue out of, now 5 add 4 add 3 is 12 sweets altogether. If I've taken a blue out, I've then got 1 less blue in the packet and 1 less sweet overall. So the probability of me taking another blue sweet would be 4 out of 11. The probability of taking yellow and another yellow would be 4 out of 12 for the first pick, but then if I've taken a yellow out, the next one is going to be 3 out of 11. And the probability of red and then red again is going to be 3, because there's 3 red, out of 12, times by, if you've taken that one out, there's then going to be 2 left out of 11. So when we want 2 things to happen, we times along the branches. That would be 20 out of 132 here, 12 out of 132 here, and 6 out of 132 here. When we multiply fractions, top times top, bottom times bottom, and then we would add those all together. They've all got the same denominator. We have to make sure they've got the same denominator when we're adding or subtracting. 20 add 12 add 6 is going to be 38 out of 132. So that's the probability of getting the same colour both times. But we were asked in the question the probability that the 2 sweets are different, and that's going to be the rest. So I know that 1 whole is 132 out of 132. So let's do 132, take away 38, more on the floor, borrow from next door, 12 take 8 is 4, 12 take 3 is 9. So therefore our final answer here is going to be 94 out of 132. That would be my probability of them being different colours, because it would be all of those other branches. Question number 17. Y is inversely proportional to x squared. When y is 10, x is 3. And then x is directly proportional to z when x is 5, z is 10. Find a formula for y in terms of z. Give your answer in its simplest form. Okay, so y is inversely proportional to x squared. When we have inverse proportion, it's going to be 1 over the thing they're saying, and we can't solve equations with fish in them. So we just write that as an equals, and we need a k. That k is what connects the 2 things. So we're saying that y and x squared are connected somewhat. As one gets bigger, the other one gets smaller. But that connection we show with a k. And then they're always going to give us a pair of values. And that's going to allow us to work out what the k is. So 10 is k over 3 squared. I'm just substituting in the values they've given us. 3 squared is 9, and I'm going to times both sides by that 3 squared, by that 9, and that gives me 90 equals k. Once you know what k is, go back to that equation and write y equals that k value now being put in over x squared. So I'm going to put a box around that because that is my formula. Now let's move on to the next one. X is directly proportional to z. If it's direct proportion, it's just going to be on the same line. X equals k z. Again, we're taking that fish symbol out. It's actually a loose alpha, but I like it better calling it fish. So equals and a k, that k connecting the 2. This is a different k. It's quite confusing using the same letter, but it weirds me out too much to use a different letter. So there we go. I'm going to put 5 equals k times 10. I'm using the values they've given me. And dividing by 10, be careful not to fall into the trap of putting 2 there. I'm dividing by 10, so 5 over 10 is k, which means it is a half. So I can then go back to the second thing I wrote, that equation, and now say that x equals a half z. Okay, there's that formula as well. So I've got 2 formulas, but it says find a formula for y. So we want y equals, but we only want it to have z's in it in terms of z. I've got y with x in it, and I've got x with z in it. So let's combine these 2 things. So I want y equals, and at the minute I know that y is 90 over x squared. So x squared, but instead of that x, I want z's. So I'm going to use the fact that I know that x is a half of z, and I'm putting that there where that x value is. So y equals 90 over a half z squared. Now I don't want to leave a fraction within a fraction, so this is 90 over, now when you square a half, it becomes a quarter. So this is a quarter z squared. Each of the values in the brackets needs squaring. And then I'm going to multiply both the top and the bottom by 4 to get rid of that fraction. So 360 over z squared. That is my final answer. I've times the top by 4 and I've times the bottom by 4 to get rid of that fraction and give that nice final answer. So y is 360 over z squared. There we go, 5 marks for that one. Question number 18, solve 3x add 5 all divided by 2 minus 2x minus 1 all divided by 3x equals 5. Now whether you're adding fractions with algebra or numbers, we know that that denominator, adding or subtracting, that denominator needs to be the same. So I'm going to make both of these fractions out of 6x. 6x is the first multiple of both 2 and 3x. So I'm going to use 6x as a common denominator. Now you might have got that by just multiplying them together. When you multiply them together, because you've times this 2 by 3x, you also need to times the top by 3x, and because you've times this 3x by 2, you also need to times the top by 2. So it makes this kind of shape where you're multiplying out. So I'm going to do 3x, lots of 3x add 5, over 6x, minus, and then over here, be really careful because it's 2 lots of 2x minus 1 over 6x. Now I haven't actually multiplied anything. I haven't actually made anything bigger or smaller. I've just used equivalent fractions there. So that's all over 6x. In fact, let's just make that one big fraction. So let's put that like that. And that's all over 6x, and there was a minus here. Now be really, really careful with expanding this out. A lot of students would have just doubled this and made it 4x minus 2, but you're taking both of those things away. So this minus is going to affect both terms. So my next line is going to be 9x squared, add 15x minus 4x, add 2, because it's negative 2 times negative 1, all over 6x equals 5. Now let's get rid of that fraction by multiplying both sides by 6x. So I've got 9x squared, add 11x, because I've got 15x take away 4x, add 2 equals 30x, and then we're going to take 30x away from both sides because this is a quadratic, so I want it to equal 0. So 9x squared minus 19x, add 2 equals 0. And now we're going to factorise that. So I'm looking for putting that into brackets. Now that's going to be quite tricky. Now you might do the a times c method. Let's do that. 9 times 2 is 18. So we're looking for two values that multiply to make 18 and add to make minus 19, because that's the term in the middle there. And that's going to be 1 and 18, but minus 1 and minus 18, so that then they add to make minus 19, but they multiply to make positive 18. So then I'm going to split the middle into those two values. So 9x squared still goes here, minus 18x minus x, add 2 equals 0. So I've split the middle. You can put 1x if you find it helpful. And then I'm going to factorise these two parts and factorise these two parts. So 9x multiplied by x minus 2. And then I want this second bracket to be the same. So I know it's a minus 1 I'm taking outside there. And so your brackets are 9x lots of x minus 2 minus 1 lots of x minus 2. So altogether 9x minus 1 lots of x minus 2. So x equals 2 is one of your solutions, and x equals 1 over 9 is the value that would need to go here to make that bracket equal 0. So those are your two solutions to that quadratic. X equals a ninth and x equals 2. Question number 19. The graph of y equals f of x is shown below. On the grid above, draw the graph of y equals f of x minus 1. Now, when we have the minus 1 inside the bracket like this, anything inside the bracket affecting the input is going to change the x direction. And when it's inside the bracket, it actually does the opposite of what you would think. So minus 1, you'd think that would go left. It doesn't, it goes right. So I'm going to take a few values and map them one space to the right, one unit to the right, and then I'm going to sketch it there again. So that is what it should look like. 1 square over like that. There we go. That is the graph of f of x minus 1. Then it says write down the coordinates of the turning point of the curve with equation y equals minus f of x add 1. Now anything outside the bracket is affecting the y direction like this. So add 1 does indeed go up 1, and a minus is a reflection. So f of minus x reflects across the y-axis and reflects left to right, but minus f of x, which we've got here, reflects up to down, as everything does when it's outside the bracket, and reflects across the x-axis. So we need to do both those things. We need to reflect it and we need to move it up 1. So I'm going to take this point here. Let's do this in different colour actually. Let's do this in pink. So I'm going to take this value here and reflect it up here. And I know that these would stay the same like that. That would be the reflection. But then we also need to move it up 1. So the turning point would end up being here. So the coordinate that I'm going to put there to get the mark is 1, 5. That is my coordinate of the turning point if it's reflected in the x-axis and then moved up 1 as well. Brilliant. Well done if you got that. Question number 20. Here are two similar shapes, shape A and shape B. The total volume of shape A is 32 pi. Okay, there we go, that one. And the total volume of shape B is 256 pi centimetres cubed. Calculate the radius of shape A. Okay, so shape A is this one over here, and this is what we want. We want the radius. So at the minute, we know the volume of shape B. Now the volume is made up of two parts. It's made up of a cone and it's made up of half of the sphere, so a hemisphere, just the bottom half. So I'm going to write what I know so far. I know that the volume of B is 1/3 pi r squared times height. Add. Now you can take this and divide it by 2, but it's far easier just to work with 2/3 pi r cubed. Instead of 4/3, which would be a whole sphere, I just want 2/3 because that would be a hemisphere, half a sphere. And we know that those two things added together equal 256 pi. Now we know the radius is x, and we know the height is 10x. So let's fill those in. 1/3 times pi times x squared times 10x, add 2/3 pi x cubed equals 256 pi. Now everything has pi in it, so I can divide by pi and get rid of those. I'm then left with 1/3 of 10x cubed, because I've got x squared times x there, add 2/3 of x cubed equals 256. Now these are both x cubed, so I can collect these like terms. 1/3 of 10 could be easy for me to just put 10/3 there. And we're adding 2 more thirds. So altogether, I've got 12/3. And 12/3 is just the same as 4, 12 divided by 3. So 4x cubed is 256. And then we can divide both sides by 4. So let's use our bus stop method there. 256 divided by 4 is 4 into 2 doesn't go. 4 into 25 goes 6 times, remainder 1, and 4 into 16 goes 4 times. So x cubed is 64, and if we cube root that, we get that x is 4. Great, so I now have the value of x. I know that this is 4, and this would be 40. So I've got this radius, but I know you're thinking, how on earth does that help me to get the radius of this one? Well, we were given the volume. So now, using those two values, 256 pi divided by 32 pi, if we cancel that down, 256 over 32 is the same as, let's half it, 128 over 16, half top, half the bottom, equivalent fraction. That is 64 divided by 8, and so that is 8. This is 8 here, so the volume scale factor is 8, and if the volumes are 8 times bigger, we know to get the linear scale factor, the difference between the lines, we can cube root that. The cube root of 8 is 2. Out of interest, if you wanted to know how much bigger the areas were, that would be 4 because that's 2 squared. So the lines are 2 times bigger. If this length is 4, then we know that this length here would be 2 because they are similar shapes. So there we go. Our final answer for that question is 2 for 5 marks. I really hope you enjoyed that paper. I hope you found it helpful. Please let me know in the comments if you've got any questions. Feel free to check out my YouTube channel and also over on TikTok. I've got lots more content there if you'd find it helpful, and good luck with your GCSEs.